the cloud. Oh, your homework is due Thursday
How do you want to do lunch?
for
That's
8.
what I'm thinking about.
So don't forget about that.
We'll just chill here till lunch.
Mhm.
Then go from there.
Yeah.
Which I'm so glad you just go here.
Sorry.
Yeah, I didn't put 7-3 on there. It may be on the final, but I won't put it on here. Yeah. So for anyone who didn't hear, there is a mistake on here. I haven't fixed it. If you can figure out what the mistake is, you get a couple bonus points.
I didn't hear what he said. He said
You'll get the
bonus
same
points.
thing either way. Yeah. It goes 10, 15, 25, 25, 20, 10. Yeah. It's not that bad. All right. Let's go through this thing real quick. This is the last section of chapter 9. My least favorite section. And then we're on to 10. 10's easiest because you do it on the calculator. I don't make you show the work really.
Just go to P.
Yeah.
Oh, we just did a
Now, for the first 2 sections, we've been talking about doing a hypothesis test for the difference between 2 means. And then the third section, we did it for when the means were dependent. So we tested the difference. So we did a 1 sample t-test on the differences. And that's what your bonus was about. Does anyone want to know the answer to the bonus? It's already up. Okay, cool. Some of you got it right. Some of you missed some points. So most of the errors were if you did, the decision rule was wrong. So if you have a left-tailed test, the decision rule is reject the null hypothesis. If you get a test statistic less than the negative critical value, some of you put the absolute value of the test statistic as less than negative 1.86 or whatever it is. Is the absolute value of anything ever going to be negative? The answer is no. So some of you got 4 out of 5 instead of 5, and that's why. And some of you whenever you write the null and alternative, you just put something equals 0 and something is less than 0. But what is that something? So make sure you put the parameter in there. That'll be very important on the exam and on the final. So whenever you write the null hypothesis that mu d equals 0, just don't put equals 0, write what parameter you're talking about, or just say mu1 minus mu2 equals 0. Now, onto this section, we're going to talk about testing the difference between 2 proportions. Okay, let's go orange since we're at OSU. Oops, that was not good. How do I go back? We'll go here. Then, in this section, just like we did in chapter 8, we did a z-test for the proportion. So we're going to do a z-test for the difference between 2 proportions in this one. Then it says, let's review our previous proportion notation. So it says P is the population proportion, just like we said before. And 1 minus P is, oh, there you go. Sorry. It was muted over there. People online, can you hear me? Great. Then your book denotes Q as 1 minus P. Nothing new. P hat is the sample proportion for one sample. It's the number of people who have some characteristic divided by the total number of people in the sample. And in the book, Q hat is 1 minus P hat. So it's just a complement of it. Now, in this section, we're looking at 2 proportions. So we're looking at 2 populations. So you're going to put a subscript for each of them, just like we did for the sample means, or for the population means. So P1 and P2 are proportions for populations 1 and 2 respectively. And you can find P1 hat and P2 hat by the same idea. You have X1 over N1, where X1 is the number of people who possess some characteristic of interest. N1 is the sample size for the first group. And then P2 is the same thing, but for the second group. And then something you'll need to know, P bar is the weighted estimate of P. So it's the pooled proportion. So it should take the number of people who possess some characteristic of interest in the first group and the second group. You add those two numbers together and then divide by the total sample size. And in the book, Q hat is just 1 minus P hat. So your homework does, I think it tests you over this, oops, over that, and over that. Then the assumptions that we make for a two proportion test, both samples are random. For both samples, this one's kind of weird. Whenever we had a one proportion test, what was the second assumption? N times P is what? Greater than or equal to 5. And N times what? 1 minus P is greater than or equal to 5. And that's for both N1, P1, N2, and P2. Now, what is that last one supposed to say? The samples are what of each other? There's only two possible words that could go there. Yeah, it's independent. Samples are independent of each other. So in 9.3, they were dependent because we were looking at the exam scores or something of one person. So it's going to vary from person to person. Then you have this thing again. I would review this middle part here. For some of you at least, the decision rules. I know it's not in your homework, but it's an easy way to figure out what the decision is at the end, whenever you get the test statistic or the p-value. Now here's the fun part. The formula for the test statistic and for the confidence interval. I felt bad because last semester a student asked for help on this and I gave them the wrong one. So z-test is equal to, my stomach is growling, I am hungry. DoorDash will be delivering food to my office shortly. Minus P2 hat. So the difference of the proportions minus P1 minus P2 divided by the square root P bar times 1 minus P bar times 1 over N1 plus 1 over N2. And recall what I just said on the previous page, that P bar was the pooled proportion. So it was the number of people in the total sample that possess some certain characteristic of interest divided by the total number of people in the sample. Can that be simplified anymore? Yeah, under the null hypothesis, this is 0, so this goes away. So you're just left with the difference between the two sample proportions divided by the corresponding standard error. Now the confidence interval formula. Still have the same point estimate. Oops, someone has their mic on. We're going to turn that off. Allow participants to unmute themselves. Yeah, sure. I don't think you want to hear any bad words again. P1 hat minus P2 hat. So that's the point estimate of the difference between the two population proportions, plus or minus. We're still going to use a critical Z value. Something else that I noticed on the bonus. So whenever you do a one-tailed test, what is the subscript of the critical value. Yeah, alpha, not alpha over 2. If you're doing a two-tailed test, it'd be alpha over 2 because the area is being distributed into two tails. If you're doing a one-tailed test, it's just alpha. Then times the corresponding standard error. P hat for the first group times Q hat divided by N1 plus P2 hat times 1 minus P2 hat over N2, and that's all under the square root. I don't like this section because I got confused with these two formulas before. Do y'all want to do the first example or want me to do it? Yes, I can. All right, we'll go through this example, then we'll look at a couple from your homework, and then I guess if you want to, we can fill that out, or I can just show you what it is. Okay, it says a study found that in a random sample of 50 burglaries, 16% of the criminals were arrested. In a random sample of 50 car thefts, 12% of the criminals were arrested. Alpha is 0.1. Can it be concluded that the percentage of people who committed burglaries and were arrested was greater than the percentage of people who committed car thefts and were arrested? In this case, I mean, you can first identify what you have for P1 hat and N1, P2 hat, and N2. You'll have to find, oops, that should be N2, not N1. And then X1 and X2. Now, let's just say burglaries is the first group. And what is P1 hat in that case? The number of people who got arrested and committed burglaries is what? Yeah, 16% or 0.16. 0.16, and the sample size for that was what? 50. Then you can find X1 by what? Remember, P1 hat is equal to X1 over N1. You have P1 hat, and you have N1, so just multiply them. If you do 0.16 times 50, what do you get? Yep, 8. So X1 is 8. There, where in the world is it? Try to make it a little better. 8. Everyone okay why that is? To solve for X1 here is multiply by N1 on both sides. Then for P2 hat, so that's the sample proportion of people who committed car thefts and were arrested. What is that? Yeah, 0.12. 0.12. And what is N2? And doing the same idea to find X1, what do you get? 6. Now you have all of that. That'll come up later. The first part, state the null and the alternative. What's the null? The two proportions are what? Equal. So you can say P1 minus P2 equals 0. Or you can just say P1 equals P2, either way. What is the alternative? They're what? At alpha is 0.1, can it be concluded the percentage of people who committed burglaries and were arrested was what? Greater. So what's the relation between P1 and P2 in that case? P1 is greater than P2. Or you could write it as P1 minus P2 is greater than 0. Then what tail test are we doing here? You're doing a one-tail test on which tail? Right, because it's greater than. How do you know that? Yeah, so the tail is dependent on this sign here. If you're doing a greater than, under the alternative, you're doing a right tail test because you're looking at the area in the right-hand tail. If you're doing a left-tailed test, so the alternative would look like this, P1 is less than P2, then you would be looking at the area to the left of that test statistic that you get. If you're doing a two-tailed test, you're looking at the area to the left of the negative test statistic and the area to the right of the positive one. I actually have a thing for it. So I'll show you how to do it. Yeah. Where did I actually put that? It's in here somewhere. Where's overleaf? Can't remember if I put it in here or not. Log in. If you're curious how I make your little review topics, this is how I do it. There's it on here still. Dang it, it's not. I'll have to find it, but I'll show y'all how next time. What was I on again? This. It's all dependent on the word, really. Whether it says was greater, was less, or differs, something like that. Then since we're doing a right-tailed test, the critical value is going to be what? Positive or negative? Positive. And in this case, at alpha is 0.1, what is the critical value? To find that, you just look at the probability of getting a z-score. Since you're doing a right-tailed test, it's greater than the critical value. So you have a positive z alpha. And this area is equal to what? Alpha, which is 0.1. Then what is the area to the left of that critical value? 1 minus that, so 0.9. So look for a z-score in the table such that the area to the left of it is 0.9. And tell me what you get. This implies that z alpha is 1.28. Then, writing the decision rule for a right-tailed test, you have reject the null hypothesis. If you get a, since we're doing a z-test, it'll be a z-test statistic. And since you're doing a right-tailed test, you want to reject if you get a test statistic greater than the critical value, greater than 1.28. That makes sense to everyone? Then compute the test statistic and the corresponding p-value. I cannot tell you enough. Know how to do this for the exam. If you don't, you'll probably lose 15 points. Then the test statistic, just using the formula. So z-test. Whoa, why did that? Z-test. In the numerator, you had what? The difference between the two proportions. So p1 hat minus p2 hat. So you just look at that, 0.16 minus 0.12. And that is why I always list these out over here, because that way you know what to plug into the formula. If you do that on the exam, I may give you a bonus point. Then divide that by the corresponding standard deviation. Now in the denominator, you needed what? Yeah, p bar. So what would you do? Yeah. X1 plus x2 is what? 8 plus 6 is 14. And then divided by 50 plus 50, 100. So it's 14 over 100 or 0.14. So this would be 0.14 times 1 minus 0.14. And multiply that by 1 over n1, which is 50. Where in the world is the eraser on this thing? Select objects. I don't know. Just mark that out. Plus 1 over 50 again. And that's all into the square root. Someone besides Randall, tell me what you get. Yeah, correct. 0.58. So that's the test statistic. Now, since it's a right-tailed test, we're going to find the p-value for this by looking at the area to the right of that test statistic. So to find the p-value, you look at the probability of getting a z-score greater than your test statistic, 0.58. Now the table will only give you the what? Left-hand area. So take 1 minus that to find the right-hand area. And the p-value is equal to 1 minus the probability of z being less than or equal to 0.58. And what is that? Anyone figure it out? If you look at the area to the left of 0.58 in the table, what do you get? Yeah, 0.7190. So you just take 1 minus that. 1 minus 0.71. Yep, 0.2810. So that's the p-value. Now, you can take this p-value here and compare it to alpha, or you can take the test statistic here and compare it to the critical value. Either way will give you the same decision. Let's do it this way. Is 0.58 greater than 1.28? No. So you fail to reject using this right here, using the critical value. What about this? What in the world? There we go. Why is it doing that? No. Josh is not a happy person right now. Okay, what about the p-value? I don't know how in the world to fix it. There it goes. Ta-da. What about the p-value? What is it in relation to alpha? Close. Flip it. It's greater than. 0.28 is greater than 0.1, right? So therefore, you fail to reject using that as well. Either one will give you the same decision. I mean, it's fine either way. The p-value is just an extra step. It's just to show you that you get the same decision either way. What, the p-value part? Yes. Then reach conclusion and make an interpretation. So that means make the decision. So what was it? Yep, so fail to reject the null hypothesis. And then let's write the conclusion. Thus, we cannot conclude the percentage of people who committed burglaries so I'm going to short that burg and were arrested is greater than that of cart thefts. That's the conclusion. Oops, 4 people have responded in the chat. Was that earlier when I said, yep, okay, cool. That was when I said, can you hear me? Everyone okay with that conclusion and the interpretation? Yeah. Oops. All right. Let me see if I have one of your homework problems or not. I know an easy way to get to it. Hopefully it'll let me preview it or something. There. Lovely. Oh, no, cool. It's not gonna make me do it. There. Assignments. Chapter 9. Print. That'll let me access it. How many of you actually started on this? It's 9. Cool. Is there a specific one you want me to look at? Anyone? Let's do this real quick. Send this to Notability. Create new note. Here. This section right here. That and the p-value. P-value always gets people in 8 and 9. There, let's look at, I guess this one right here is number 3. It says a researcher wishes to see if there's a difference in the manual dexterity of athletes and that of band members. 2 random samples of 34 selected for each group and are given a manual dexterity test. The mean of the athletes test was 86, and the mean of the band members was 88. The population standard deviation for the test is 7.3. So that just means sigma 1 and sigma 2 are both 7.3. Use mu1 for the mean of the athletes. That alpha is 0.01. Is there a difference in the mean scores? Use the p-value method and the table. And do you want to go through the parts first? Do you want to identify the individual pieces you need? Okay. Then we're doing a test for what in this case? the mean or the proportion, that's all I'm asking. So we need x1 bar, not S1, sigma 1, and N1, and x2 bar, sigma 2, and N2. Now it says use the first subscript for the athletes. Then what does the sample mean for the athletes for the test? Yeah, 86. Says the standard deviation for the test. Make sure you know how to determine whether it's a population or a sample. On the exam, it very clearly states. On the last exam, I didn't think I stated it clearly enough. So I made sure to bold and underline it. So if you miss it, I don't know what to do. 7.3. What is N1 sample size for the first group? 34. What about the second group for the band members? What is the sample mean? 88. What about the same standard deviation and the same sample size, 34? Now, the first part, state the null and the alternative and identify the claim. What is the null? Yeah, mu1 equals mu2. What is the alternative? Yeah, is there a difference? So mu1 does not equal mu2. Which one is the claim? The claim is what it's asking you to test. Yeah, the difference. So the alternative is the claim. Claim, not claim. This hypothesis test is what? One-tailed or two-tailed? Two. Because of the not equal to. Everyone okay with that? Now the next part is compute the test value. So how did you find the test value? Z-test was found by, this is section 9.1, x1 bar minus x2 bar divided by what? Sigma 1 squared over N1 plus sigma 2 squared over N2. Then, using that, what do you have in the numerator? Yeah, 86 minus 88. And in the denominator, the square root. And note, it only gives you sigma, not sigma squared. So you have to take that 7.3 and square it. So it'd be 7.3 squared over 34 plus what? Yep, same thing. 7.3 squared over 34. Someone tell me what you get, because I have no idea what it is. Negative 1.12. Negative 1.13. And that's what goes here. Keep in mind, this will not be the same exact question as yours. Alex automatically just assigned you one. And there's a lot of different ones it could give you. Now this is the hardest part. Compute the p-value for the two. It's a two-tailed test, so you're going to look at the area to the left of the negative test statistic and the area to the right of the positive test statistic. In this case, you got a test statistic that was what? Negative. So just look at the area to the left of that and do what to it? Multiply it by 2. Then the p-value is equal to 2 times the probability of z being less than negative 1.13. That would be 2 times whatever that is. Negative 1.13. 0.1292. And what is that? Should be 0.2584. Is that right? And that's the answer to that part. What if it was just a left-tailed test? What would the p-value be? You're just looking at the area to the left of that negative test statistics, so it would be that. Then make the decision. You can either look, oh, I guess I don't give the critical value. So just look at the p-value and compare it to alpha. Is it less than or greater than it? 0.2584 is greater than 0.01, right? So then do not reject. Then the worst part of the question. This part. There is blank that the mean manual dexterity test scores of athletes and band members are different. Now, the claim was what in this case? Null or the alternative? Alternative. That means this part here, where it says to support or reject, it will be one of these. Because you're gathering evidence to support the alternative, and the alternative is the claim. Which one is it though? Yeah, not enough evidence to support the claim. This one. Why? Since we failed to reject the null hypothesis, that means we can't support the alternative. Does that make sense? That's why. Yes, correct. Yeah, basically, kind of. In a way, yes, but technically you can't say it's true, but in a way, yes. Is this the one that? Why in the world does it mention this? It does it on another one of them too. Let's look at it. It mentions like these things up here. It says the California yearly average is this, and this is this. I don't know why it tells you that. You don't use it in the problem anywhere. Whenever you look at these, just look at this stuff right here. That's all. Because that's the mean and the population standard deviation for each of them. That's all you need. I don't know why it gives you that stuff at the top. This is the same thing. Okay, let's look at this one. Oh, wait, is there another one like that? That one. Okay, let's look at this one. Is there a significant, what does it say? That's just it. Is there a significant difference at alpha's 0.1 in the mean heights and feet of waterfalls in Europe and the ones in Asia? The data is shown below. Use the critical value method with the tables. It says use mu1 for the mean height of waterfalls in Europe. Assume the variable is normally distributed and the variances are unequal. In this case, how would you find the mean and the standard deviation for each group? Just use your calculator or use Excel. Either one works. You want me to show you how to do it? Let me grab my calculator. Let me switch the camera to over here. 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 And then stop screen sharing. Pen. Then in the first column, put the Europe heights of the waterfalls. So stat, edit. What in the world is that? Clear list. L1. L2. L3. Then in the first list, put the Europe. So you have 487, 900, 12, 46, 13, 12, 1385. And then the next column you have 614, 350, 722, 320, and 830. Now you want the sample mean for each of these and the sample standard deviation. How do you find that? So just go stat, go to calculate. In this case, you don't want to do one variable statistics, you want to do two variable statistics and tell it L1 and L2, the first and second column. Don't worry about the frequency list thing and then hit calculate. So for all the X stuff, that's the first column. That means the sample mean height for the waterfalls in Europe is 1056. So we have X1 bar is equal to 1056. And S1, so the sample standard deviation for the first one is 373.321. 373.321. I'm just using 3 decimal places because you're gonna have to square it anyway. And then N1 for this one was 1, 2, 3, 4, 5. And then look at the Y as this corresponds to the second one for Asia. That mean height was, we have X2 bar is equal to, in that case, it was 457.2. S2 was what? Oops, didn't go far down enough. 313.855. Then N2 is again 5. Then let's go back over here to this share, oops, screen, start. Okay, there we go. Now we're back to here. So I just listed all the stuff in there. Then the null and the alternative. So what is the null? Yeah, so mu1 is equal to mu2. And what is the alternative? Yeah, is there a significant difference? It doesn't indicate whether it'll be greater than or less than. So it's mu1 does not equal mu2. And then which one is the claim and which one is not the claim? You're testing whether there's a difference. So this is the claim, the alternative. This is not the claim. And then it's obviously a two-tailed test since you're doing not equals. Then, since the two-tailed test, let's find the critical values. And what kind of critical values are we going to have, Z or T in this case? T. You only know S1 and S2. So you'll use critical T values with degrees of freedom of what? 0.1. If you do that, you're going to look at degrees of freedom is 4, a two-tailed alpha of 0.1, and then take the positive and the negative of that value. Do that, we go 4.01, two tails. What is that? Anyone got the table on them to look at it? Yeah, 4.604. And since you're doing a two-tailed test, you want to take the positive and the negative 4.604. Everyone understand how I did that? Then compute the test value. Just plug it into the formula. So let's do that up here. So it'll be T test is equal to X1 bar minus X2 bar. So 105.6 minus 457.2 divided by the square root of S1 squared over N1 plus S2 squared over N2. So that would be 373.321 squared over 5 plus 313.855 squared over 5. Someone tell me what that equals. $2.745. Okay, so that would be this part, 2.745. Then make the decision. So does it fall within those two critical values or outside them? Falls inside them, right? In between negative 4.604 and positive 4.604. So it falls within the do not reject region, so you do not reject. That makes sense, Randall? Then summarize the results. So this case, we had the claim was the alternative, so it's going to be down to these two. And which one is it? Not enough evidence to support the claim. Everyone okay with that? Now let's look at one from 9.4. That's the same thing. What does this say? This one's a confidence interval. Let's do this one here. Number 11. In a sample of 49 men, 38 said they had less leisure time today than they did 10 years ago. In a random sample of 49 women, 30 women said they had less leisure time today than they did 10 years ago. At alpha is 0.05. Is there a difference in the proportions? Do you want to identify P1 hat and P2 hat now or do it later? Now, so P1 hat is going to represent, so let's do the first group is the men. So P1 hat is equal to the sample proportion of men who had less leisure time today than they did 10 years ago. And 38 said they did out of the 49 total, so 38 out of 49. And then we have N1 is equal to the sample size for the men, so 49. P2 hat is equal to the proportion of women who had less time today than they did 10 years ago. And that is what? Yeah, 30 over 49. And N2 is still 49. And now you're gonna need P bar in this case too. And that's equal to what? X1 plus X2 over N1 plus N2. So that would be 38 plus 10, or 38 plus 30. So that would be 68 divided by 49 plus 49 is 98. And you have all the stuff you need technically so far. State the null and the alternative hypothesis and identify the claim. What's the null? The two proportions of both groups are what? Equal, so P1 equals P2. And the alternative, what is it? You can find the last line. At alpha is 0.05, is there a difference in the, yeah, so not equal. So P1 is not equal to P2. And since this is what we're testing, this is the claim. And again, it's two-tailed. Then since it's a two-tailed test, there's going to be two critical values. Anyone tell me what they're going to be? Alpha is 0.05, two tails, and you're going to use critical Z. Yeah, positive and negative 1.96. Then find the test value. Do that. Let's do it up here since we have more room. And Z test would be equal to 38 over 49 minus 30 over 49 divided by square root of 68 over 98 times 1 minus 68 over 98 times 2 over 49. Does everyone know where I got that 2 over 49? 1 over 49 plus 1 over 49. Someone tell me what you get. So you had, in the very end, you'll have 1 over N1 plus 1 over N2. So that'd be 1 over 49 plus 1 over 49. So just add the numerators. Holy cow, I have no idea if that's right or not. Let's see. Let's see. Check. 38 over 49. You may be right though. I don't know. Minus 30 over 49 divided by the square root of 68 over 98 times 68. Oops, not minus. Times 2. Yeah, it was a little off. 1.75. So that's the part C. Then make a decision So it was 1.75. Yeah. It falls within the positive and negative critical values, so therefore do not reject. And in this case, okay. So there is or is not enough evidence to support the claim that proportions are different. Yeah, it's not because you failed to reject. Then y'all can do that part. Find the 95% confidence interval for the difference of two proportions. That's just using the confidence interval formula. Let's see if I can get it first. Oops. Crud. So this would be the square root of the square root 38. Plus oh my, so then this. Anyone think they have it? Plugging it into the calculator is actually quite nasty. Let's see if I can do it this way too. Test. Sample. X1. Wait, 163. 2. What's it? There's another way you could do it too. If you know how to use the test function on the calculators. It's not funny. That one's a lot easier than this. Do it the same thing. If you haven't figured it out, your calculator is it does your homework a lot quicker than some of you probably do. So your calculator can do all the tests it asks on homework. If you didn't know that. Except whenever we do a t-test for the difference between two, because it uses a different degrees of freedom. But if you go in and hit 2 prop z interval under test, it'll automatically do it for you. If you tell it x1 and n1 and x2 and n2 and tell it the confidence level. Or if you do it by hand, you'll get the same thing. Anyone get the lower limit? It's negative. Let me tell you what it is. Negative 0.0163 to 0.34288. You want to know how to do it on the calculator? Okay, I'll show you. To do it on the calculator, you go stat, go over to test. In this case, you want to do a 2 proportion z interval. So just go 2 prop z interval. Right here. Option B. Tell it x1. So in that case, it was the number of males who have less leisure time now than they did 10 years ago, divided by the total number of men in the sample, 49. Let's pin this picture if I can real quick. I don't know if I can't. So you tell it x1 and then n1 and then x2 is the next one. And then n2. And you tell it the confidence level as a decimal. So if alpha is 0.05, the confidence level as a decimal is 0.95 or 95%. Then go down, hit calculate, tells you the interval. Or you can do this. This is the numerator, the difference between the two proportions, and that is the denominator. That's the lower limit, negative 0.0163. That's the upper limit of 0.34287. On the exam, I expect you to at least show some work as to how you got what you got. Upper, it was point, dang it. Yeah, something like that. I'm just going here and hit plus. 0.34287964048. That's what the calculator gives you. Now it'd be the answer to part 6. Everyone okay with that? Great. Now you can spend the remaining 12 minutes trying to find my mistake in the exam. The first one to get it gets bonus points. It's in the practice exam. It's not anything grammatical. Where in the world did I put it? Is it in Notability? All notes, no. Recent, no. Oh, I guess it didn't there. Let's do this, Word. Word. Is it a, oh, is it a PDF? There it goes. Why is it not showing the answers highlighted in red? Save a copy. My iPad, just do that. Dang it. Does it show the answers in red on Canvas? Okay, cool. Oh, I guess I'll just put it up here in the room. That way it's a lot easier to see. Stop. Share. Here. Okay, whoever finds it first gets a couple of bonus points. Someone online, you can try it too. What? No. It actually has to do with something I said today. What the? Oh, and number 17, I wouldn't ask for the p-value. It's the t-test. What? No, it's not that mistake. It's a mistake in how I answered one of the questions, what I marked. Anyone online, have you found where the mistake is? Uh, what do I want to get? I think a Panera Bread. No one gonna try? Shoot, wrong button. Someone was close. No. 15? No. I don't know. Let me check. That may be another mistake. What can you conclude from the analysis? The technician is correct. No, that's right. And you have to tell me what the correct one is. If you don't want to try, you're free to go. You can't see how that's. Oh. Yeah, it's weird. Is it what? No. What? Okay, so in this case, we rejected the null hypothesis. So we're in favor of the alternative, right? So that means we're supporting the fact that the mean diameter is greater than 3. That's what it's saying.
Okay, so that's why we can say it's
Yeah, yes. Anyone figure it out? I don't know, should I? No, I shouldn't. It's on the screen somewhere. Yeah, I know. I just saw that over here. That's why I scrolled to this question. Yeah. No, it's not. You think you got it, Reagan? It. Uh-huh. And what should the correct answer be? Yes, correct. C is the correct answer. This is for a two-tailed test. This is the answer for a one-tailed test. That is the mistake. I found it this morning. Yeah, correct answer C. I'll update it in Canvas in a second. All right, well, I guess we'll review for the exam on Thursday. We'll go through the practice exam. And also, if you can print out the other sheet that I put the review topics on, it may be very helpful to look at the homework question numbers and the examples. Hint, one of them may be on the exam.